Welcome again to another tutorial on how to use R for statistics and research. In this lesson, we are going to learn how to set up a completely randomized design in R. A completely randomized design relies on randomization to control for the effects of extraneous variables. The experimenter assumes that, on average, extraneous factors will affect treatment conditions equally, so any significant differences between conditions can fairly be attributed to the independent variable. In CRD, there is only one primary factor under consideration in the experiment. That is why the CRD is the simplest of all experimental designs. The treatment levels or groups are assigned to plots or subjects at random. The statistical model for the CRD can be written as y sub ij equals mu plus tau sub I plus epsilon sub ij, where y is the response variable and tau is the explanatory or independent variable. Y sub ij pertains to the value of the dependent variable or response variable attributed to the jth replicate in the ith treatment. Mu is the theoretical mean of all the possible responses. Tau sub I is the ith level of the treatment, so that if you have three treatment levels or groups, then tau sub I can be tau sub 1, tau sub 2, or tau sub 3, where tau sub 1 can be your control variable, for example. Epsilon sub ij is the random error assigned or attributed to the jth replicate in the ith treatment level or ith group. Notice that this is what we call a effects model because it highlights the effect of the ith treatment level to the response variable y sub ij. Now, if we combine mu and tau sub I, then the sum mu plus t sub I, tau sub I, is equal to mu sub I, and we end up with the means model. If we have three levels or three groups, then we can write mu sub 1 equals mu sub 2 and mu sub 3, and end up with the null hypothesis for the analysis of variance. Now, how do we set up a completely randomized design in R? Quite simply, we can use the sample function in R. The sample function has the following arguments. We have the vector to be randomly assigned, the sample size, and to determine whether we will allow replacement or not. In this case, we will allow replacement in order for these treatment levels or groups to be assigned repeatedly until such time that we have a sample size of 12. If we try to hit Control and Enter, then we will see that we can get an output of something like this, where C is assigned for the first plot. Let's say A, B, and C here are types of fertilizers, and our 12 samples here are plots of rice, say for example. And so here, fertilizer C is assigned to the first plot, B to the second, C to the third, B to the fourth, C to the fifth, C to the sixth, B to the seventh, B to the 8th, C to the 9th, A to the 10th, B to the 11th, and B to the 11th. If you try to run the same command again, we see that we don't get the same output. That is because the sample function is a random generator in R. If we want to get the same output every time we run sample, then we have to set the seed, say for example at 2, and we now get the same sample every time. Now, if we want to store the result of sampling to an object in R so that we can retrieve it anytime, you can assign it to an object like, say for example, TRT. And we can now get the number of replicates assigned to each treatment level. So in this case, we have 4 for A, 3 for B, and 5 for C. So as you can see, in the completely randomized design, the assignment of replicates may not be balanced. It may be unbalanced, as in the case here. But there may be cases where we want the design to be balanced, and that can be achieved with the help of the Agrecolate package. If you haven't installed the Agrecolate package, you can install it by typing installed packages, then Agrecolate. I have already installed it, so I will load it using the command library Agrecolate here. Now the function that we will use in order to generate a randomized complete randomized design in R is the design.crd. And if you put a question mark before the function and run it, then we'll get this output here, which gives details on how to use the design.crd function. So the design.crd function generates completely a randomized design with equal or different repetition. Random uses the methods of number generation in R, and the seed is by set.seed kinds, as we have discussed earlier, this one, set.seed function. So what are the arguments for the function? Well, we need to supply the treatments, the number of replicates, and conditionally we can also supply these arguments. The series, the seed, the kinds, and the randomization. But for our purposes, it's enough to assign only the treatment and the replications. So say for example, we have a sample size of 12 and we want to randomly assign the 3 fertilizers to 12 plots, and we want to end up with a balanced design such that each fertilizer is assigned to 4 plots. Then we can write design.crd TRT is equal to C, A, B, C, and R equals 4, and end up with this setup, where C is assigned to the first 3 plots. And as you can see here, R has a running number 1, 2, 3, and ends up at 4 when C is again assigned to plot number 109, or to the 9th plot. And as you can see here, B is also assigned to 4 plots, and finally A is assigned to 4 plots. There may be a reason for assigning more replicates to a certain treatment level or group. In that case, we can explicitly state the numbers of replicates each treatment level will have. For example, if we want A to have 5 replicates, B to have 4 replicates, and C to have 3 replicates, we can write design.crd TRT is equal to C, A, B, C, R is equal to C, 5, 4, 3 instead. And if we do so, we end up with this setup where the first 2 plots get C, the 10th plot gets C, and the rest gets A or B. Alright, so this is how you can set up the completely randomized design in R. Now let me remind you that our example here of fertilizers and plots is specific to this discussion. You can actually replace the plots here by test tubes, and the fertilizers here by concentrations of a particular chemical. So The actual setup will depend on the kind of problem that you have. Now, the next topic is a step up in setup difficulty to the completely randomized design, but it's still not so complicated. It's called the RCBD, or the Randomized Complete Block Design. So until then, thank you for listening, and I hope that you got something from this tutorial. Until then, bye.